And the next topic that we're gonna have is the nutrition and prevention of civilization disease and the high antioxidant effect of special olive oil from this earth. By the lecturer is
Dr. Sean Paul Curtis. Dr. Sean Paul Curtis is one of the uh, pioneer of therapy and author of many renowned scientific books such as The New Guide to Vitamins, prefaced by the Nobel Prize in Medicine. And now he is president of Green Health, a movement for global health, a member for the New York Academy of Science, and a member of the authority team for the Journal of Nutritional and Environmental Medicine. And now, let's give a warm welcome to Dr. John Paul Curtis.
Hello, nice to be here with you in this country I like very much. So, before starting with the specific olive oil polyphenols, may I just give you a little reminder of what is the interest of polyphenols in general. Polyphenols are thousands of molecules, over 6,000 have been identified, that are secreted by plants in order to defend themselves against any kind of stress. For instance, when a plant lacks food, water, when it's too hot or too cold, when they are attacked by bacteria, viruses, parasites, fungi, for instance, inflammation, toxics, they will secrete polyphenols. I give you a sort of a concrete example. In Africa, when giraffes come to eat the leaves of acacia tree, the tree will release gas, and this gas will diffuse to the whole tree the message that it's attacked. And in response, the tree will secrete more polyphenols, sort of long-chain polyphenols, polymers that are called tannins, and make the leaves indigestible by the giraffe. And moreover, this gas will carry the message to neighboring trees. Even though they have not been attacked by giraffes, they will secrete more tannins to be prepared to resist the giraffe attack. And this kind of mechanism is what does the polyphenol in the plant world. So another mechanism of defense is that it will reduce the energy expense by the plant towards reproduction. Why? Because the energy will be then channeled toward all the defense mechanisms. For instance, immunity, antibacterial defenses, to make more energy, to detoxify, to repair the DNA, which is a very important interest in anti-age medicine. Actually, the polyphenols have a similar effect as caloric restriction. As you know, caloric restriction is the most verified experimental way to prolong longevity, maximum longevity. Over 200 species have been tested. And for instance, resveratrol, that you know from red wine, has been used and mimics caloric restriction without caloric restriction, which is kind of interesting. But it's not specific to resveratrol because other polyphenols have been shown to be able to do the same. And also, the most recent breakthroughs, I would say, from a team from Scotland, Andrew Collins, who invented the famous Comet assay to show the number of DNA breaks, and a Portuguese collaborators, shown recently that 3 polyphenols increased the activity of DNA repair genes. You know that there are 125 DNA repair genes identified, and rosmarinic acid, for instance, rutin, luteolin, that we'll find in olive oil, are polyphenols that stimulate DNA repair mechanism. So this whole mobilization of energy towards defense, antimicrobial, anti-toxic, anti-inflammatory, anti-famine, caloric restriction, or anti-dryness, and so on. All these mechanisms are called hormesis. Hormesis. It's a very important notion today because that's the hormesis adaptation that explains as well the caloric restriction and the polyphenol impact on anti-aging and the prevention of degenerative disease. So that's a general feature of all polyphenols. It's not specific to olive oil polyphenols. It runs for green tea catechins, for flavanols from cacao, for citroflavonoids from orange and lemon, for oligomer prosanidolic from grape seeds, etc. I said there are thousands. Pomegranate is very well known, punicalagin from pomegranate. This is not specific, it's general to all those famous polyphenols. Another common feature of polyphenols is that they are more potent antioxidants than the regular classic antioxidant that you know, like vitamin C, vitamin E, etc. That's when you test, ORAC will see some studies, lipoperoxidation. On different tests, the polyphenols are much stronger, several times more than those classical antioxidants. That's another point. The third point is that when you use classical antioxidants like vitamin C, and that there is too much iron or copper, and you may know that in case of inflammation or even psychological stress, we know that thanks to a Japanese researcher, Yagi, noradrenaline gets iron inside the cells, which explains mainly the inflammation response to even psychological stress. So when you have iron and copper going up, and that you have to defend yourself only classical antioxidant, unfortunately, these antioxidants are destroyed and generate free radicals. It's called the Fenton reaction, for instance, for vitamin C and copper or iron, that generates the most aggressive of all free radicals, hydroxyl radical. Okay. So there is a big problem, as you can see, is that the supposed antioxidant become pro-oxidant, do the opposite in many situations of iron and copper overload, inflammation, psychological stress, overload of estrogens, also elevates copper, as in the pregnant women. In all those situations, or in case of pollution, the antioxidant do the opposite of what they're supposed to do. And what's interesting for polyphenols is that, on the contrary, polyphenols can chelate iron and copper, those pro-oxidant and pro-inflammatory metals, and stabilize them. They don't become pro-oxidant as vitamin C. And the last interesting common feature of all those polyphenols is that they have a tropism for connective tissue. And that has been known for years, decades even, by phlebolog doctors that treat vein problems, because high doses of polyphenols like rutin or from plants are used in this phlebology field. Okay? But then a researcher, Ladislas Robert, discovered that this is absolutely not specific to phlebology. It happens that the polyphenols go to the connective tissue of the veins that are too dilated, and that will have an antioxidant and AMP, cyclic AMP effect of venotonic, and that is common to all polyphenols, go into all connective tissue. So as you know, all organs are wrapped into connective tissue. The muscle with fascia, the brain with meninge, the the muscles, the bones, periost, all the organs are wrapped, even the vessels, veins and arteries are coated with connective tissue. Story of olive polyphenols. This I pass on my curriculum vitae that was already talked about. So why are we interested in olive polyphenols? That there is another problem, which is not a real advantage of polyphenols, is that contrary to all the advantages I described, they have very poor bioavailability. They are poorly absorbed, they can be catabolized by the liver, and you have a hard time to get enough, for instance, curcumin. Everybody heard of curcumin in turmeric, which is a fantastic polyphenol with anti-inflammatory mechanism in all ways of inflammation that can oppose all cancer stages: initiation, propagation, angiogenesis, invasivity, metastasis. And as you know, in Japan, for instance, they use curcumin as a chemotherapy, okay? But curcumin is very poorly absorbed. And it's the same problem with the catechins from green tea, including epigallocatechin galate, which is the most interesting. It's the same problem with punicalagin from pomegranate. It's the same problem for most of these polyphenols. So one first element of response that we have to better the situation is that it was discovered that most polyphenols are fats, can be better bioavailable with fats. They are half water soluble, half fat soluble. And that's the case you'll see in a study with olive oil. When you have the polyphenols in the oil, you have a better absorption. So that's one point. A second point is that the gut flora, we talked a lot about gut flora this morning, can hydrolyze, pre-digest long-chain polyphenols. The longest are tannins. Tannins are totally unabsorbed. And if you lack iron, which is not so good for a woman because she'll be tired and she'll be more vulnerable to infection and she'll be less concentrated because you need iron to synthesize noradrenaline for concentration, then if she drinks a lot of green tea, which is good for health, we all agree, at the meal, she will block iron absorption. So you have to tell your patient if she lacks iron, she can drink green tea, but not after a meal rich in iron. She can, once the iron is absorbed, 2 hours or 3 hours later, she can drink green tea, or in the morning, if at breakfast there is no iron-rich food, okay? So the first point is that those tannins are totally unabsorbable, but still they are interesting because we said before that if you don't like iron, iron is a pro-oxidant, and as you know, women live on average in the world 7 years longer than men. And one of the main explanations is that they have periods, and that every month they lose blood with iron. And that is, of course, not the only, but one today considered as the main explanation of why women last longer than men. It's because they, every month, lose iron. So eating too much meat, particularly for a man who has no period, is not such a good idea, you can understand. And though tannins block iron absorption, and that's good for men, that's good for women after menopause, they have no longer periods, okay? And so that's still useful to have tannins, even if it's not absorbed. And those tannins also can chelate heavy metals in the gut and get them in the toilet. Other toxics, they have some protective role, reduce the mutagenicity of feces. So basically, even though they're not absorbed, it's still interesting. Then you have smaller polyphenol chains, but still too big to go to the blood, okay? Then the bacteria from the gut can cut in smaller pieces those polyphenols, and so the gut flora, we talked so much about it this morning, I don't know if anybody talked about this morning, but we can add an interest of the good flora is that it will help the bioavailability of the polyphenols by digesting them and also by activating them. For instance, punicalagin, the pomegranate polyphenol, as you all know, is proven very interesting in the prevention and even treatment of prostate cancer. But punicalagin is a polymer very badly absorbed. It has to be cut, okay? So the flora is very important. And then, when it's cut, it becomes ellagic acid, a polyphenol from strawberry. But ellagic acid does nothing for the prostate. What do you find in the prostate in people who take pomegranate polyphenols? You find urolitins. And urolitins are catabolites from bacterial action of genes in the gut of ellagic acid. So, pomegranate polyphenols cannot be active against prostate cancer without probiotics or a good flora, and everything we said this morning, we remember maybe if you were there, that we need to eat more fiber, vegetables, less fast sugar, less saturated fatty acids, more polyphenols, omega-3, that will help to have a long-term good flora. And that's important in connection with action of polyphenols. Another example is phytoestrogens. You know that in Asia, women have 5 to 6 times less breast cancer than in the Western societies. It's also multifactorial, of course. But phytoestrogen of soy are one of the contributors to this. They are diazein and genistein. They are antioxidant, they have interesting effects, they antagonize endogenous estrogen, estradiol, okay? But diazein does nothing by itself. It does it as equal is a catabolite of gut bacteria, of diazein, okay? And so on. We could take many examples of the fact that polyphenols have to be activated by the gut flora. Okay, so that's the second answer to the bad bioavailability of polyphenols. And the third answer is, smack in the subject of my talk, is that you have naturally very small polyphenols, like the one from olive oil, particularly hydroxytyrosol, which is the star of those olive oil polyphenols, which is so small and fat soluble that it can cross easily the barrier to go from the gut to the blood, and even from the blood to the brain through the blood-brain barrier. And that, of course, makes it particularly interesting. So I propose that we go through these studies that show the interest of this. So you have in the fruit 20%, 22% of oil, 50% of water, and the rest. You have, you know, the green of the olives on the tree, and then they become mature, they become purple. And they become purple when they get richer in polyphenols. That's when they have to be picked. Okay. So what are those olive polyphenols? They are a whole family, and you see in red, the most important of them is hydroxytyrosol, because it was the one that showed the most active principle. But also oleuropein, which protects the brain and the neurons, and the luteolin we talked about when we evoked the polyphenols that stimulate DNA repair mechanism. Luteolin is one of the most potent anti-inflammatory polyphenols of all the polyphenols studied, and has this particular ability of stimulating the genes of DNA repair mechanism. What is its origin? It's simply a catabolite of oleuropein. Okay, so you can see also that there is more polyphenols of olive in tree leaves. You can also get extracts from tree leaves, but in the tree leaves you have no fats. So unfortunately, you need to have fats to have better absorption, and we'll see a study where the polyphenols from the oil has better bioavailability. So let's see more into this bioavailability. When you do radioactive isotope, you can see that it's ingested about, it goes through the blood about 10 minutes after ingestion, has a half-life of about 1 to 2 minutes, and in 5 minutes you find it in all the main organs, the heart, and then it appears last in the brain. You can see also on this graph that the bioavailability is higher in oil than in water. Okay, and then it's catabolized as by several pathways, 3 main pathways. Okay, so what is the antioxidant potential or potency, let's say, of these olive polyphenols? Remind here the Fenton reaction we talked about that goes from hydrogen peroxide to the hydroxyl radical, which said it was the most aggressive of all free radicals, OH point, and this can damage anything. Cell membranes, proteins, DNA, etc. You all know that. So, of course, the interest of antioxidants, they can interfere with this destruction or help repair the damaged molecules. So, when you compare these polyphenols with vitamin C and vitamin E, the metabolites appear more efficient against lipoperoxidation and oxidation of proteins. Remember, they are as well fat-soluble and water-soluble. You can see the ORAC of hydroxytyrosol is 40,000 when vitamin C is 2,100, and resveratrol, which is very good, is only half the ORAC of hydroxytyrosol. Is hydroxytyrosol toxic? Of course, we have to ask this question. So we have studies on that, and we'll see that there is a let's say the dose of active principle that's needed for effect is rather low, 6 milligrams at 12 milligrams a day, whereas the dose that is toxic is 2.5 to 3.5 grams per kilo. There's a huge safety margin. Basically, there is hardly any toxic effect, even though it's absolutely not interesting to overdose in polyphenols. You remember that polyphenols are also weapons from plants to defend themselves. So if you overdose in polyphenols, you can finally get some liver damage. You can see on the green columns the consumption of olive oil in the countries. Greece is the world champion, Spain, Italy, Mediterranean countries. Now it's coming to Asia slowly. And you see in blue the columns of cardiovascular disease incidence. And you can see that there is a relationship, except for Japan. Japan has a lower rate of cardiovascular disease than Mediterranean countries, even though olive oil has come to Japan, but is still marginal. You cannot say it's not a commonly used product, even though it's getting better known, of course. So in Japan, there is special features. People eat less than in USA, for instance, or in westernized country. They eat more fish, less meat. They eat soy, phytoestrogens. They have usually more polyphenol. And the most dramatic, of course, is Okinawa, where you have the world record of longevity, 61 centenarians for 100,000 people. In France, which is one of the top countries in the world, we have 22 centenarians for 100,000. So they explode the score, 3 times more centenarians than in the best countries. They have 1,500 times more what we call super centenarians. That means people over 110. And 5 times less cardiovascular disease, 5 times less breast cancer, 6 times less prostate cancer, and so on. So it's, as you know now, Okinawa blew somehow to say the Mediterranean model, because there's something in Okinawa. I wrote a book about this, and so it's not the subject today, but I guess if the Okinawans took more olive oil, they could do better. But also black chocolate, which is not at all from Okinawa. So they could do better, but today, in the facts, Okinawa is the world champion on longevity and prevention of degenerative disease, and it's not due to olive polyphenols. So means that, of course, you cannot do anything with one magic bullet. It's a whole picture. And in Okinawa, they like many things, like moving. They don't take, they don't retire. They have lots of humor. They eat less. They do caloric restriction. They eat about 200 less calories than in Japan mainland, and 300 calories less than in Europe, and 500 calories less than in United States. And as we said this morning, caloric restriction is a very powerful tool, but it's a global picture. Okay. So a study with Mediterranean diets rich in olive oil in Naples with 180 persons that have metabolic syndrome. Okay, so we look into even some pharmacological therapeutic effect, and we can see that it improves endothelial function, arterial pressure, ameliorates the lipid profile, ameliorates insulin sensitivity, lowers platelet aggregation, and reduces inflammation markers, so that at the end of the 2-year study, 66% of this group of 180 were no longer suffering metabolic syndrome. That's a fairly spectacular, but also, again, it's not only the olive oil, because it's the Mediterranean diet, which means eat more fruits and vegetables, eat less meat, etc. Okay, plus olive oil. Okay. So the main benefit of olive oil cannot be attributed to monounsaturated fats, the fats of olive oil. This is clear when you do a meta-analysis of studies, when you look into the scores, the health scores, overweight, diabetes, inflammation, cancer, neurodegenerative disease, in people who eat a lot of monounsaturated acid, fatty acids. You have lots of monounsaturated fatty acids, for instance, in geese and duck fat, in almonds, in avocado. So you don't have to have olive oil to have a rich diet in monounsaturated acid. And so you can compare population who have at the same amount of monounsaturated fatty acid, olive oil or not olive oil, and it appears that the benefits for inflammation, for cardiovascular disease, for cancer, and so on, is not linked to monounsaturated acid, because people who eat a lot of monounsaturated fatty acid have some benefits, but much lower than when there is olive polyphenols. And then we look into study on the lipid profile in 200 men, 20 to 60 years old, in 5 countries, Mediterranean countries and Scandinavian countries, which they have there a very bad cardiovascular health profile, and they receive either a very rich polyphenol oil, like the oil we'll talk about, with 360 milligrams per kilo, one half this amount, 160 milligram, and one nearly null, 2.7 milligram. And you can see that after the end of the study, the HDL cholesterol, which is the good cholesterol of return, okay? How do you get good cholesterol of return? It's when the cholesterol goes into the artery. If there is too much, it stays there and it can thicken the artery. What is the mechanism? The mechanism is that you have macrophages. Macrophages are white cells, remember, that are the garbage evacuators, okay? When you inhale a dust in the lung, you will have a macrophage eat the dust and eliminate it. If you have a virus, the macrophage will gobble it and destroy it. If you have too much cholesterol in the arteries, the leukocyte, the macrophage will gobble it, okay? So the macrophage have LDL cholesterol receptor. You remember LDL as ApoB tag, protein tag. When it's inside, the ApoB, the tag is cut and it changed to another tag, which is ApoA1. It becomes HDL. It's spit back to the blood, goes to the bile, and goes to the gut. If you eat enough fiber, the fiber will take it to the toilet. If you don't eat enough fiber, you can reabsorb the cholesterol, which is not so good, okay? So you understand that HDL cholesterol is a return form, so-called good cholesterol, through the bile, through elimination, so that it doesn't make the artery thicker, okay? What if the LDL cholesterol is not pure but altered, for instance, by oxidation? If you have too much iron, we said, if you smoke, if you pollution, you stress, you increase your iron in the cells, etc., you may oxidize the LDL, alter the tag, and then the macrophage will take the LDL cholesterol modified, so-called oxidized cholesterol, but it will not go through the LDL cholesterol receptor. It will go through a special receptor that's called scavenger receptor. So this scavenger receptor can gobble up anything, even drugs, okay? And then, unfortunately, the tag cannot be changed. You cannot make HDL, so the modified cholesterol remains in the macrophage, inside the artery. Okay, that's how you make a so-called squamous cell that will lead to atherosclerosis. So now that you see the mechanism of how you can keep HDL cholesterol being made in the macrophage to return the cholesterol via the bile to the gut, it needs to be protected from oxidation. And as we said, the polyphenols are very strong antioxidant. They are able to block lipoperoxidation, and they're very strong anti-inflammatory agent. That's the explanation that when you see that with 360 milligrams kilo per polyphenols, the HDL grows up to 1.74, only 1.20 with 164 milligrams, and under 1 when there is hardly any polyphenols, okay? So this explains why when you do a meta-analysis of studies, it was shown already in the 70s, the first studies came from Hertog in the Netherlands, showed that the more you have a daily intake of polyphenols in the diet, the less cardiovascular disease you have. Okay, that's the scheme of what happens in the artery when the cholesterol is oxidized. And also, there's a second mechanism, but in my point of view is less important, is that polyphenols can inhibit the synthesis of cholesterol in the liver, which is not so interesting because cholesterol finally is not so bad. You use it in the neurons, in the membranes. It's the precursor of DHA, that you all know has an anti-age function and so on, of CoQ10 cannot be made, coenzyme Q10 cannot be made without cholesterol. And so it's not such a good idea to take statins and to lower the cholesterol to all prices. It triggers a lot of secondary deleterious effects, and it's much better just to prevent oxidation of cholesterol so that you don't have, and I think astaxanthin does the same kind of thing. In diabetics, if you give 12.5 or 25 milligrams of hydroxystrozole every day for 4 days is a short time, okay? You can see a significant reduction of platelet aggregation and of the risk of thrombosis. Okay. They had a larger study with 38 patients with hyperlipidemia and 35 control patients who had their LDL cholesterol decreased by 6 milligrams only for 6 months. What was that? Olive polyphenols against inflammation. So you remember that inflammation is now considered a main contributor to all degenerative disease. It's very present in overweight. It's what explained the passage from overweight to metabolic syndrome, and from metabolic syndrome to diabetes, and from diabetes to cardiovascular disease. Okay? You find inflammation in all of inflammatory and allergic disease, autoimmune disease, in neurodegeneration, Alzheimer and Parkinson, and for instance, there's too much iron in the neurons, and there is a high level of inflammation that destroys the neurons, okay? So inflammation is an important target in prevention, in anti-age medicine, in prevention of degenerative disease. And we said already that when you compare polyphenols with classical antioxidant, we have a much higher potency of polyphenols, and some polyphenols are even more potent. We name luteolin that we find in certain herbs and in olive. But what is the first step of inflammation? Inflammation is carried mainly by white cells. To carry inflammation in a tissue, if you have a bruise, okay, the leukocytes will go from the blood to the altered tissue, okay? To do this, the leukocytes have to stick to the arterial wall to be able to go through the endothelium, okay? It's called diapedesis, but the leukocytes cannot do that, go out of the blood to go in the tissue without special adhesion molecules, like this VCAM1, which is, but there are many others, ICAM1 and so on, okay? Or it was shown by studies that the polyphenols can interfere between leukocytes and the adhesion molecule, and when they prevent adhesion, they prevent diabetes. The leukocyte cannot get out of the blood, and so it's a very powerful first stage inhibition of inflammation. Okay. Even before the leukocytes triggers all kinds of corrosive secretions, and that you activate NF-kappa B and mTOR and all those ways by the cytokines. If you block the adhesion, none of this happens. So you can explain, but also the researchers have shown that the polyphenols interfere then also with the other stages. They reduce the corrosive molecules emitted by the leukocytes. They reduce activation of NF-kappa B. Well, on mTOR, I haven't seen studies, but so basically, this explains why polyphenols are very potent anti-inflammatory, and that's objectivated by this study, where you can see that incredibly, when you take the two reference drugs as anti-inflammatory, diclofenac and indomethacin, the olive polyphenols have the same impact in pharmacology on inflammation. But the big difference is that diclofenac and indomethacin are also very heavy on secondary effects. You know that it's one of the 3 types of drugs that kill the most people. Okay, you can erode the gastric tissue, people have hemorrhage, and it poses a lot of problem. And so if you have anti-inflammatory drugs like polyphenols that, contrary to the chemical drugs, have protective secondary effects, it makes a whole difference, even though the potency is the same. So, knowing all that, researchers looked into polyphenols olive oil, hydroxytyrosol 6 milligrams per day, during 2 months in 99 patients with rheumatoid arthritis, which is one of the most intense inflammatory diseases, as you know. Okay. And they had a significant reduction of the symptoms and of the inflammatory markers, and on top of that, a significant reduction of homocysteine. Homocysteine has nothing to do with rheumatoid arthritis, but it's still interesting. Why? Because, as you know, when it's elevated, it's a risk of phlebitis, emboli, and cerebral vascular accident. And so we know that people who have inflammatory disease are at risk increased of cardiovascular disease. And this could be a mechanism. Added to the betterment of lipid profile, we've seen the increase of HDL, the antiplatelet aggregation, and also appears then that it lowers homocysteine. Polyphenol of olives against diabetes shows in a study in normal subject and as well in subjects with diabetes, reduction of glycemia, and also the effect that we already shown on better lipid profile. The glucose level in the diabetics treated with hydroxytyrosol decreased by 55% compared to the untreated diabetic patients. But the explanations are multifactorial. Actually, it's hypothetical, the way it works, but we know that inflammation in diabetics is very important, that it contributes to damage the pancreatic cells. What's interesting is the clinical result. And also, by the way that it's antioxidant, it can protect the insulin receptor. You know that what is altered in diabetics of type 2 is the receptor to insulin. There are 2 ways you can alter insulin receptors. One way is oxidation, and we saw that polyphenol protects against oxidation. The other way is dephosphorylation. The insulin receptor have to be phosphorylated to be active. And phosphorylation has nothing to do with polyphenols, it's magnesium dependent. And so it's something different, but if you're interested in insulin tolerance and in diabetics, and you know also that glycation plays a role on top of oxidation in aging, okay? When you reduce glycation, we reduce glycation, for instance, by caloric restriction, by choosing slower carbohydrates compared to fast carbohydrates. Sports reduce insulin insensitivity. All of that has a positive effect on aging, okay? And so magnesium has, you cannot only do everything with olive polyphenols, of course. Magnesium plays also a crucial role in glucose tolerance because you need magnesium to phosphorylate the insulin receptor, and that's a potent mechanism of insulin sensitivity. So we can infer from those studies that it's interesting to use also, among other things, okay, polyphenols in prevention and treatment of diabetes. Well, for psoriasis, I show you just one case, so you cannot take this as scientific data. Okay, one case is one case. It's not a clinical study, but it's still spectacular. Our Moroccan friends sent us these slides, and I think it's worth seeing. Some psoriasis can be very heavy to suffer because it can be sometimes not as damaging, of course, just the elbow and so on. It's known as a disease that has a heavy psychological impact. And we know it's inflammatory, and you can see that with 6 milligrams polyphenols of olive a day for 6 months, the patient was nearly cured. Okay, but that's one case. So one case is one case. It's not a study. Could hydroxypolyphenols contribute to prevention or treatment of cancer? There are many ways. We know that free radicals, as well as inflammation, play an important role in initiation, propagation and promotion, invasivity, angiogenesis. You know that we all have here cancer cells, but we kill them through immune defenses or apoptosis, okay? And as long as you don't proliferate new vessels in the cells, you don't grow beyond 2 millimeters. So you can carry 1,000 small cancers of 2 millimeters, you won't die, okay? So today, oncologists agree worldwide that inhibiting angiogenesis is a very important tool in a fight against cancer, okay? As well in prevention and in treatment. But angiogenesis is inflammation dependent as well as metastasis. Okay, you need NF-kappa B to have metastasis and so on. So if you inhibit inflammation, you do inhibit all those stages from initiation to metastasis. Also, and we don't know the mechanisms, polyphenols have been shown, and it's not specific to olive polyphenols. It's been shown with pomegranate polyphenols and with catechin of green tea. They have an anti-proliferative effect. They inhibit the growth cycle. We don't know the mechanism, but it's a different mechanism. You see in an in vivo study of tumor-bearing mice that the treatment with oleuropein at 2 milligram 0.5 kilo day has a complete regression of tumors. That was done on many cancer lines, breast cancer and so on. Well, also, and it's classical, it's not new, it's not specific to olive oil, polyphenols. Mainly all polyphenols have antimicrobial effect, antiviral, antibacterial, antiparasitic. We have studies on influenza with epigallocatechin galat, for instance, or punicalagin. It's a very potent inhibitor of influenza virus, which is interesting nowadays because of the burst of avian flu. And against dementia, where you find also excess iron in the neurons and excess inflammation, now that we know that crossing of blood-brain barrier is efficient, it's likely that it will be a good contributor. It remains to be certified by clinical studies. For now, it's hypothesis, but I think a valid hypothesis. And as an anti-aging principle, for all the reasons I said, and also one other that is common to astaxanthin, is that hydroxytyrosol has been shown also to increase PGC1 alpha, and so contributes to mitochondrial multiplication, which is a very, very important feature, because not only you have more energy to walk, to think, as shown by our friends, but also to detoxify, to repair DNA. Energy is, as we say, the nerve of war. Okay, you need energy for anything. So also to detoxify, to repair. And so if you have more energy available, more mitochondria, and also in aging, there's another very important point, that more mitochondria is very helpful, is that when you eat calories, you remember that the main source of free radicals is that you don't concentrate all free electrons in the ATP. You have a leak. It's not 100% perfect engine, mitochondria, okay? So you have electronic leaks, which give these free radicals, which are, as you know, remember, characterized by an extra electron or a missing electron, as unpaired pair of electrons. It's an unbalanced molecule that will destabilize any other molecule. So that's why we get rancid and we rust on foot. Okay, that's aging because of those free radicals. So if you eat calories with oxygen, you make ATP. You have to have oxygen to burn the calories, okay? You make some free radicals, it's unavoidable. Okay. If you eat less calories, caloric restriction, Okinawa, then you live longer and you make cancer, Alzheimer, later, okay? Come back, I'm not ready. That's the philosophy of Okinawa. So you understand why. It's because if you eat less, you make less free radicals, okay? But if you have more mitochondria, you divide the work of caloric burning and you make more energy with less calories and you make less free radicals because you have more tools to do better the job. Okay? So sport, increasing the muscle, you duplicate mitochondria, astaxanthin, hydroxytyrosol, arginine. There are several known factors, nutritional factors that increase PGCA1 alpha, is top for the question that interests us, is anti-aging and prevention of degenerative disease. So, okay, I was asked to leave some time for questions, so I guess we have a summary here, as you have in the print. So maybe we'll go through the question if you have questions on those polyphenols. Yes, yes. Something I want to say that's particular, excuse me, I forgot, is that you remember that polyphenols are weapons against stress, all kinds of stress. Lack of water, too hot, too cold, parasitic, viral, microbial infection, toxics, anything, okay? Hormesis will lower energy in reproduction, increase DNA repair, detoxification, immune defense, remember? Okay. So what happens when you give to, in agriculture, lots of fertilizers and lots of pesticides? You reduce all the stress and the content of polyphenols of the grown fruits, vegetables, cereals goes down. Okay, it was proven at one of the leader in the world campus of agronomy that's the University of California in Davis. They grew the same kiwi trees, okay, on the same soil, half with organic methods and one with industrial methods, and there was much more polyphenols in the kiwi, and we have many other studies that show the same thing. Okay. What happens with the olive polyphenol from Morocco? that are used to make this extract of hydroxytyrosol. Happens that they are in the mountain, in high altitude, on an arid, very dry, inhospitable terrain. And that's explained why you find in those particular Moroccan olives from the mountain very unusual high polyphenol content. Okay, that's all I wanted to say. Thank you for your attention, and I'd be happy to answer your questions.